Hello, my name is Emmanuel Maltonam, and I'm joined by.
Hello, Tijan.
This is our video Viva Defense for our capstone project. The title is the design and implementation of an edge computing door access system using deep learning and multi-phase detection logic. We were supervised by Mr. Maxwell Subokbiri. Project overview. We are to develop an intelligent door access control system. The project leverages deep learning-based facial recognition algorithms on an edge device. All the processing is done locally on the hardware, moving away from cloud-based systems, which reduces latency, enhances privacy protection, and maintains operational continuity during network outages. Core capabilities of our system: real-time authentication using convolutional neural networks, logic-based anti-tailgating to prevent collaborative tailgating, fail-secure locking mechanisms, ensuring that the system remains locked during power outages, a centralized administrative interface for user management and audit logging. Project objectives. The general objective is to come up with an intelligent door access control system that uses deep learning and edge computing techniques for efficient and secure facial recognition-based authentication. Our specific objectives were to implement deep learning algorithms. These deep learning algorithms were implemented directly on the Raspberry Pi and optimized for real-time edge processing, eliminating cloud dependency. Anti-tailgating logic to develop a robust multi-phase detection logic to restrict or to prevent collaborative tailgating. Administrative interface to design a centralized real-time interface for seamless user management, access logs, and auditing. Fail secure design to ensure the system maintains logged during power outages, preventing unauthorized access and compromising the security of the area. Literature review. During our review of existing systems, we found out some recurring challenges, some of which are outdated algorithms. Many systems used old techniques like hard cascade or local binary pattern histograms. These systems or techniques are unreliable in real-world situations. Tailgating vulnerability. Many systems failed to tackle the situation of multiple entry per authentication events, especially in the case of collaborative tailgating, where users allowed on other unauthorized users to follow through with them. We also have fail open risk, where we realized that many systems behaved unpredictably during power outages or failures. Administrative limitations. Many systems also lacked centralized real-time administrative interfaces. Some even required physical access to the system just to access or to manage users and credentials. We look at how our project differs from existing systems. Recognition algorithms. Old systems or current systems mainly rely on out-of-the-box sensors like the Husky Lynx camera or outdated algorithms like High Cascade, which struggle with real-world conditions. Our system uses deep learning pipelines like DLib and OpenCV, which improve performance during real-world conditions. Tailgating prevention. Many systems fail to detect multiple faces in a frame, allowing multiple entry. Our approach ensures that only one face is allowed per authentication event. Administrative interfaces. Many systems rely on rigid administrative interfaces like SMS commands or physical access to the system. Our approach uses a mobile app built with React Native to remotely add or revoke user access and manage access logs. Methodology. We adopted the experimental research approach. This involves prototype construction, iterative testing, and simulation to validate performance and reliability. Hardware architecture. Our hardware can be divided into these five main components: processing unit, which is the Raspberry Pi 5, the vision system, which is the camera module, motion detection, actuation done by the solenoid lock, and safety monitoring done by the limit switch to detect the status of the door. Over here on the side is our block diagram for the system, showing the various inputs, processes, and outputs.
I will continue from the system logic and operational flow. So over here we have five steps here. The first step is the ideal mode, which is the standby mode. So with this mode, with this stage, only the PR motion sensor is active, and when motion is detected, it now moves to the detection and then count phase. So the detection and count phase, we check for the number of phases that have been detected in each frame. So if the number is more than one, we deny access to prevent tailgating. If it's less than one, or if it's equal to one, then we now move to the next step, which is recognition and processing. So with the recognition processing, we now compare or we generate the facial encodings and embeddings of the face that we detected, and then we compare it to our local database to using the deep learning algorithms. So once we do the comparison, then we now move to the access decision. So if the face that we generate, encodings that we generated matches any one in our local database, and we now give access. We trigger the lock to give access or to unlock. If there's no match, then we deny access. And for every this thing that's or every access attempt, we log an event. So they are all events. So we log all of them to the database. So we capture some of the details and then log them to the administrative interface as well. Yes. System flowchart. This is a step-by-step breakdown of the system operational logic, illustrating the sequence of events from motion detection to access, decision, and login. So the first step is so we have two flows here, an entry flow and an exit flow. So the entry flow starts from the power on. So you power on the system and then it goes on standby and only the motion sensor is active. So when motion is detected, the camera is turned on and then the camera starts capturing faces or detecting faces and then counting the faces in each frame. So once the number of faces exceed one, then we deny access to prevent anti-targeting. And if is equal to 1, we now move to the next step where we generate the facial encodings. We compare it to our local database, and if it matches, we unlock the door for the person to enter. And if it doesn't match, then we log the event and then we deny access. So when the door is unlocked, we have a limit switch over there. So the limit switch monitors to see when the door uh, closes so that we can trigger the lock to lock it for to prevent tailgating again over there. So the limit switch also monitors that too. So once the limit switch it gives a positive feedback, we trigger the lock to lock the door, and that's the entry flow. So for the exit flow, we have the motions and the push button inside the door. So when you trigger the push button or when you press it, it's going to trigger the relay to switch to unlock the door, and then once the door is unlocked, the limit switch to keep on monitoring the limit switch to see when the door closes so that we can lock the door again. Yes. The final prototype. So we have the final prototype over there, as you can see in the image over here. So inside the door contains the Raspberry Pi 5, the camera, the log, the power, the power supply, and all the other components that are used in this particular project. And then we have the system architecture where we have the backend and the front end. So the backend is into two aspects where we have the Raspberry Pi client, which contains the entire this code base for executing for executing Python script such as the OpenCV and the deep libraries for facial recognition processing. And the second part has a server that contains that connects the backend and then the front end that connects the Raspberry Pi and the front end as well. And we have the front end, which is the Raspberry Pi mobile app, which has the administrative interface for providing remote management capabilities. And then we have the system interface, which where we have the input and then the output. So with the input, we have the motion signal, which we are taking from the PR motion sensor, and then we have the video stream from the camera model. That's the Raspberry Pi camera model 3. And then we have the output aspect, which is the mechanical log actuation, and then we have the data access log transmitted to the administrative interface. Performance results and analysis. So over here, we've illustrated the performance analysis of our testing of the entire system. So the first part is recognition accuracy. So when we tested the system, the highest or the maximum recognition accuracy that we had was 96, but it varies based on environmental condition or lighting conditions in the area. Right? Then the second part is the false accuracy rate. So in all the testing that we did, we haven't come across and we haven't done any tests that give access to unauthorized individual. So always it's only it denies unauthorized people entry. So that's why we have the 0% recognition accuracy, and then we have the telemeter provision over here. So over here we had 90% success here because we are using the multi-phase detection logics over there. So once there are two phases over there or there are multiple phases captured in the frame, there's not going to be an entry. The entry is going to be denied, so we won't get access to the system at all. Yeah, so that's why we have 90% accuracy. Then we have the fail-safe mechanism or the fail secure performance rate, so which is 100% accuracy. So this one where we implemented logics to cut or to lock the system automatically anytime there's power outage. So here we had 100% accuracy. So anytime there's power outage or power cut, the system is going to automatically lock the door. Yes. Conclusion. Summary of achievements. So this project has successfully met all specific objectives demonstrated and then demonstrated that high accuracy deep learning models can execute effectively on edge devices or edge computing devices without cloud support. Our implementation addresses critical gaps in existing literature whilst providing practical deployable solution for high security environment. So below are some of our key contributions. So we have about four key contributions. One of them is that the system has demonstrated effective deployment of convolutional neural network-based facial recognition on resource constrained edge computing device or edge hardware, which is the Raspberry Pi. And the second part is we also demonstrated we've also implemented logic-based multi-phase detection that effectively closed the tailgating vulnerability gap identified in the previous research. Third part is that we've also deployed a centralized administrative interface enabling real-time user management and comprehensive audit capabilities. The last and final part is we've also the project has also validated field secure locking mechanism ensuring security integrity during power failures. So these projects can be applied in many different. So that's the application. So the project can be applied in many this noise ready to be applied in many high security environments such as data centers, research facilities, and government buildings, and even corporate headquarters where unauthorized access prevention is paramount. Recommendations and future improvements. So we have about four recommendations over here. So one of the recommendations that we are recommending for future improvement is the active cooling system due to the processes that's the heat generated by the continuous deep learning processing that we do on the Raspberry Pi. The system generates a lot of heat, so future projects can add cooling systems or implement cooling systems to handle this aspect of the heat generated by the deep learning logics and over there. And the second part is the multimodal orientation. So they can also add secondary biometric features such as fingerprint to further lower false acceptance rate. The third part is the cloud IoT and cloud integration. Whilst local processing is secured, optional cloud syncing will allow for managing multiple door access or door across different locations, right? And then the last part is the lightning adaptation. They can also future projects can also integrate infrared or automatic exposure control for better performance in total
So
darkness
I
as well.
just started the
Yes.
system, and then I'm coming to test to see if it will be able to recognize my face. So I've already registered my face over there, so my face is unknown. It's known, so it should be able to recognize me. So let me put my face and see if it will recognize me. So with the LED, if we get green light, that means access has been granted. If we get red, that means access is denied. So let's go closer to the frame and see what the camera. Yeah, so I've been given access, so I can now open the door, and then I can now close it. So when I close it, it should take some few seconds and then it will lock. Here we are testing unauthorized entry prevention for unauthorized users. So the system allow one phase per entry to combat the collaborative tailgating problem identified earlier on, and then we are trying to test it to see if it works. So you can see very well that when we have two people over there, access is denied because we are two. So we only allow one entry, one phase per entry. So that's why you are seeing the access being denied here, and that solved the issue of collaborative targeting discussed in the paper or the research work. Yeah.
So this is the demonstration of the inside flow. You press the push button, the door will unlock, and you open it. When you close it, after then it will lock. Wait. Then it will lock. This is for if you press it again. Sharp.
Okay.
So we are testing the fail secure operation. We unlock the door and then it is still locked. So when we turn off the power, it should go off. So you see that the door has remained locked.
This is a video demonstration of the administrative interface. So I already have the application installed in my phone, so I'm just going to go straight and log in. So when I click on that's the application, when I click on it, it opens the application, and then for the login page, it's going to be disabled because of the security distance. So the screen recorder is disabling it, but I will just put in my account details and then log in so that we can go straight to the interface itself. Yeah, so this is how, when you log in, this is how the interface looks like. So you can see the total number of users, the recent entries. So I did a manual test this morning, and then that's what we are seeing as the one recent entries over there. And then pending users. So if, let's say, you register a user here until the Raspberry Pi gets the user detail to train it, it's still going to be pending. So currently we don't have any user, and there's no pending user over there again. Right, so these are users that I removed yesterday, but their logs are still there. Right, when you remove a user, the logs are not supposed to go because they are purposely for auditing. So that's why you are still seeing them over here. So first, let's go to the process of registering a user or adding a new user. So you can basically start from here. So, but I don't want to start it over there. So I'm going to come here. So when you come here to the user, there's no user yet, so you click on the plus icon, you add the user details. So let's say Alif Tijani, so that's the employee full name, right? Like an employee of some big bank, but let's say Bank of Ghana. So then you put here too, that's the email address, and then you can put the employee number too. So okay, so let's see 00 okay 235, no, okay, let me say 138, okay, yeah, 138. And then the department, let's say engineering department. So you don't need the other information, so you can just click on continue. So the second step is to add the user images. So after you add the user details, you also need the user image. So you can either take photos, or you go straight, if you have it in your device, you go straight and select them. So I already have it, so I'm going to select them straight. Okay, so let me use this guy images. So 1 2 3 4. So I'm selecting 4 images, and then I'm going to upload them. Alright, so I already have the images here. Then I'm going to click on continue. So first, when you upload the images, we do validation on the images to see if there are faces on it or not. So because this one's, the system is able to detect the faces, that's why you don't see warnings here. So yeah, the validation has been completed. So you now click on the next. So now here we have where you can select device. So that's the now select. So that's the one we registered here. So you can see main entrance Pi. So you select the Pi here, the device here, and then you click on complete enrollments, and then it's going to send the data to the backend. And once the data gets to the backend, then it is going to be queued, right? So you can see processing image. So it's going to be queued. So now you can see training pending, right? And then deploying to Pi to is pending. So it's going to be pending until the Pi connect to the internet, and then start training the model right here. And then you can see the user that we just added here. Alright, so when you come here to it should change. Okay, yeah, so you can see now 1 user, right? The total number of users is 1 as well. So, and then this is the activity log too as well. So now you can check every event. So these are previous events that we have. So all these events were yesterday events. So you can see of them, right? Those are logs. So you can view it, and then you can go through the data over there. But I just added new one. So this one is manual, right? The other ones were not having images. So I added a manual one, and then I use the image API. So now when the event is we are logging the events, we also take the image of the user, and then the admin will be able to see it here as well, right? And then the other details too as well. And so that's it. So you can